Hi everyone, welcome back to Prakasham Tutorials. In this video, I am going to discuss about example of cross power spectral density, cross correlation function, power spectral density of output y of t, and autocorrelation function of the output y of t, and also discuss about average power of the output. The example is a zero mean white noise power density N0 by 2 is applied to a filter with transfer function h of omega is 1 by 1 plus j omega. First bit, find syx of omega and ryx of tau, and second bit, find syy of omega and ryy of tau, and third bit, what is the average power of the output. So given that the system function or the transfer function h of omega is 1 by 1 plus j omega, and also given that white noise power density is sxx of omega is n0 by 2. So this is the system function or the transfer function. In this equation, take the magnitude on both sides. Magnitude of LHS term is equal to magnitude of RHS term. On RHS side, numerator term is 1, magnitude of 1 is 1. Magnitude of the denominator term is square root of real part square plus imaginary part square. That is 1 by square root of 1 plus omega square. So take the square on both sides. Magnitude of h of omega whole square is equal 1 by 1 plus omega square. So we know that the Fourier transform of e power minus at u of t is 1 by a plus j omega, and the Fourier transform of e power minus a mod t is 2a by a square plus omega square. So first find out the power spectral density of the input x of t and output y of t, that is Syx of omega is equal to h of omega into Sxx of omega. So given that the Sxx of omega is n0 by 2, and now we are the free, and from the given that the transfer function h of omega is 1 plus j omega 1 by 1 plus j omega, and substitute those two values into this expression, Syx of omega is equal n0 by 2 by 1 plus j omega. We know that the Fourier transform of the cross correlation function of y of t and x of t is cross power spectral density of y of t and x of t. So that is ryx of tau is equal inverse Fourier transform of syx of omega. So now here syx of omega is n0 by 2 by 1 plus j omega, and substitute this value into here, we get ryx of tau is equal f inverse of n0 by 2 by 1 plus j omega. So n0 by 2 is the constant that is written inverse Fourier transform, which is equal to n0 by 2 into f inverse of 1 by 1 plus j omega. So but we know that the Fourier transform of e power minus at u of t is 1 by a plus j omega. From this equation, f inverse of 1 by a plus j omega is e power minus at u of t. So using the standard expression, f inverse of 1 by 1 plus j omega is e power minus a tau into u of tau. So therefore, ryx of tau is equal n0 by 2 into e power minus a tau u of tau. So this is the first bit solution. And second bit, so um, find out power spectral density of y of t and autocorrelation function of y of t. So we know that the power spectral density of the output y of t is syy of omega is equal magnitude of h of omega whole square into sxx of omega. From the given data, Sxx of omega value is n0 by 2, and magnitude of h of omega whole square value is already calculated here, and substitute those two values into this equation, we get Syy of omega is equal n0 by 2 by 1 plus omega square. So we know that the Fourier transform of autocorrelation function of y of t is power spectral density of y of t. So that is Syy of omega is equal to Fourier transform of Ryy of tau. So the power spectral density and the autocorrelation function of y of t form a Fourier transform pair. So that is Ryy of tau is equal to f inverse of Syy of omega and substitute this Syy of omega value into this equation. We get Ryy of tau is equal F inverse of n0 by 2 by 1 plus omega square. n0 by 2 is constant, that is written inverse Fourier transform. So which is equal to Ryy of tau is equal n0 by 2 into F inverse of 1 by 1 plus omega square. So we know that the Fourier transform of e power minus a mod t is 2a by a plus 2a by a square plus omega square. So now here in this equation multiplying numerator and denominator by 2. So we get 1 by 2 into 2. 2a by a square plus omega square. Now here the a value is 1. So using that expression, Fourier transform of e power minus a mod t expression, f inverse of 1 by 1 plus omega square is e power minus 1 mod tau. So therefore, Ryy of tau is equal n0 by 4 into e power minus mod tau. This is the second bit solution. And third bit, the average power is Ryy of 0. Now here Ryy of tau is calculated. In this equation substitute tau is equal to 0. We get average power. Substitute tau is equal to 0 n0 by 4 into e power minus mod tau. E power minus mod tau value is 1. Therefore the average power value is n0 by 4.